In this video, we are going to explore expressions and we're going to try to apply them in real life situations and word problems. Let's begin. So, an expression. An expression is a mathematical sentence or mathematical statement. One of the jobs of a mathematician is to convert real life situations into a mathematical expression. So, what do we mean by that? Well, let's imagine the following scenarios. How would a mathematician convert these real life situations into mathematical expressions? So we have this little paragraph here, and it's about Mr. Green. Mr. Green went to the store to buy apples. He bought 3 apples and brought them home so his wife could make apple pies. Mrs. Green yelled at him because he didn't buy enough and demanded he go back to the store because she needed more apples for her pies. So Mr. Green went back to buy 7 more apples. How would a mathematician write an expression to show how many apples Mr. Green bought that day? Now, this seems like a complicated story. What does this have to do with math? Well, a mathematician would take the information and try to turn it into something that he could do calculations with. So he bought 3 apples, and then he had to go back to the store so that he can get 7 more apples. So 3 apples plus another 7. And that's it. That's our expression, 3 plus 7. Now, we can also write it another way. We can say if we're being asked to write an expression to show how many apples he bought that day, we can just say 10 because he went to the store and got 3 and 7, and you could simplify. So we'll learn about that in a moment. So 3 plus 7 or 10 are 2 ways a mathematician could write this expression. Let's take a look at another example. Sherry made $500 by selling 100 baskets of berries Saturday morning. In the afternoon, she had to refund some customers who returned 6 baskets because the berries were moldy. How would a mathematician write this expression to show how many baskets Sherry sold that day? Well, she made $500 by selling 100 baskets, but 6 of them were returned. So how many baskets did she sell? Well, she sold 100. Not 500, but 100. She made $500 initially. So she sold 100, but what happened? Well, 6 were returned. So 6 were returned. So you would say 100 minus 6. And that's pretty much the end of the story. You could write your expression this way, or you can simplify it and say 94. Example 3, Christian always runs 7 miles every Monday, Wednesday, and Friday. That's a much shorter story. How would a mathematician write an expression to show how many miles Christian runs every week? So, he runs 7 miles, and he runs it Monday, Wednesday, and Friday, so that's 3 times a week. So 7 times 3 is one way we could have written it. You could have also written it this way. He runs 7 miles every Monday, then 7 miles on Wednesday, and 7 miles on Friday. So 7 plus 7 plus 7. Or you can just say he runs 21 miles. Let's try example 4. Mario went to Gino's Pizzeria to buy 4 pizzas. Gino's was selling pizzas for $5 per pizza. Mario was able to get a discount because he brought a coupon that said, save $6 on your next order. How can we write an expression to show how much money Mario paid for the pizzas? So he got 4 pizzas and they're each $5. So he got 4 pizzas times 5 because 4 pizzas for $5. But he was able to get a discount that said save $6 on your next order. So he got a coupon that saved him $6. So 4 times the 5 gets you the $20, and then you subtract $6, which is how much his coupon was for. So you could have written it this way. You could have written it like $20 minus $6. You could have written it 14 after simplifying everything. So hopefully that makes sense. Simplifying. An expression can be made up of many terms and operators or a single term. And we did that in the previous examples. We had like expanded expression, and we also had a simplified expression with like a single number. So when you try to write an expression in the simplest way possible, it is called simplifying or solving the expression. So Mia spends 90 minutes at every soccer practice. She goes every Tuesday and Thursday. Write 2 expressions to show how much time Mia spends at soccer practice each week. Well, we could say how much time does she spend each week? Well, she goes 90 minutes every Tuesday and 90 minutes every Thursday. So that's one way of writing it. Or you can just say she spends 90 times 2 because she goes twice a week. Or you can say 180. all of those are, you could have chosen any two of those. Example 6, Drake weighed 170 pounds in the fall. In the winter, he gained 15 pounds, but in the spring, he lost 20 pounds. Write two expressions to show how much weight Drake weighed. Well, he weighs 170 pounds, and he gained 15, so that's plus 15. But he lost 20 pounds, so that's minus 20. So that's one way you can write it. You can also write it this way, 70 plus 15, which is 195. And then minus the 20 he lost in the spring. Or you can simplify it further and say 165, which is, that's it. It's 165. It's after he's gained the weight and lost the weight. All right, using variables. Some situations are more complicated. Now, this is getting to the real stuff. They include terms that are unknown terms or whose values can change. Don't think about that too much. Actually, we're going to get into those problems. In these situations, we use a variable to create a algebraic expression. Now, a lot of people are comfortable with unknown terms, but a term whose values can change, how does that mean? What does that mean? Well, you'll hopefully understand after this next example. So variables are values that can change or they are unknown. All right, so we're going to make an algebraic expression rather than just the regular expressions we were making before. And remember that an algebraic expression has a variable in it. That's what separates it from a regular mathematical expression. Alex and his little sister Beth get an allowance from their parents. As the kids get older, their parents give them more money for their allowance. Because Alex is a year older, he always gets $5 more than his sister. Write a word expression for how much allowance Beth gets. Okay, so what information do we know? We know that Alex gets $5 more, or conversely, we know that Beth gets $5 less. All right, what don't we know? Well, we don't exactly know how much Alex's allowance is, and we don't know what Beth's allowance is. So write a word expression for how much Beth gets. Well, we don't know how much she gets, but we do know that she gets less, $5 less than Alex. So that gives us a clue. So our word expression would be Alex's allowance minus 5. That's how much she gets, is Alex's allowance minus 5. So going further, rather than writing words, mathematicians use a variable to save time. So right here, this is our expression, Alex's allowance minus 5 is how much Beth gets for her allowance. But mathematicians don't want to write whole words out. They would rather just shorten it by using variables. So can we write an algebraic expression for how much allowance Beth gets? Define your variable. Well, we can just say A is Alex's allowance, and we minus 5 from it. So we need to define our variable. We just need to tell our reader that, hey, A is Alex's allowance. A means Alex's allowance. So A minus 5 is going to be Beth's allowance. And A is Alex's allowance. So let's say Alex gets $10. That means Beth is getting $5. Let's say Alex is getting $11. That means Beth is getting $6. If Alex is getting $12, Beth is getting $7, because it's always $5 less. And that's what we mean about a variable could be a number that changes. All right, can we write an algebraic expression for how much allowance Alex gets? Well, let's see. We know that Alex gets, we don't want to just say A, because that's, we don't want to put, A, he gets A, and that's how much Alex's allowance is. No, we want to refer it to something else. Well, we know that he gets $5 more than Beth, so we can just say Beth's allowance plus 5. So if we know Beth's allowance, we add 5 to it, and we'll know Alex's allowance. So we need to define our variable. That B is Beth's allowance. Let's move on to the next example. Office Depot has a special back-to-school sale special where they give away a 4-pack of pencils when customers buy a notebook. Yay! Write a word expression for how many pencils Office Depot gives away. Well, what do we know? We know that they give away a 4-pack of pencils. Oh, whoops. They give a 4-pack of pencils away for every notebook sold. But what do we not know? We don't know how many notebooks are sold. We just know that they give away 4-pack of pencils for each notebook sold. So our expression would be for how many pencils Office Depot gives away, we would say the notebooks sold, number of notebooks sold times 4. If you find the number of notebooks, whether it's one notebook or 10 notebooks, that'll give you you'll be able to figure out how many pencils are sold. So imagine 5 notebooks are sold. That means 5 times 4, that means 20 pencils are given away. Anyhow, can we write an algebraic expression for how many pencils are given away? Well, it's the number of notebooks sold times 4. So n is going to be the number of notebooks. You can also write it as 4n, because this is 4 times n, and 4n means 4 times n. So, and remember, when you multiply, the order of the numbers doesn't matter. So remember n, define our variable, n is the number of notebooks sold. Now, can we write an algebraic expression for how many notebooks are sold as opposed to how many pencils are given away? Well, if we knew the number of pencils given away and we divide it by 4, because 4 times more pencils are given away than notebooks. So if we take the pencil numbers given away, divide that by 4, that will let you know how many notebooks are sold. So you can also write p divided by 4 as this, p divided by 4 in fraction form. Anyhow, let's define our variable. P is just the number of pencils given away. Let's go on to number 9. You try this one. McDougal's Burgers always sells its burgers for 25 cents less than their competitor, Burger Queen. Write an algebraic expression for the cost of a McDougal burger. Okay, well, we don't know how much McDougal sells its burgers or Burger Queen, but we do know that McDougal's sells their burgers for 25 cents less. So if Burger Queen sells it for $1, then McDougal's is 75 cents because it's 25 cents less. If Burger Queen sells it for $2, then McDougal's sells it for $1.75. So if we know the cost of a Burger Queen burger, we can say B for Burger Queen burger, and we subtract 25 cents from it, we'll know the cost of a McDougal burger. So what does B stand for? Is that the cost of a McDougal burger, minus 25? No, that's the cost of a Burger Queen burger. So B minus 25. How about example 10? When Gabby waters her plants, she needs 4 times as much water for her ficus plant as her cactus plant. So cactus does not take as much water. So I was like, write an algebraic expression for how much Gabby waters her cactus. Well, do we know how much she waters her cactus? No. We know that it's 4 times less than her ficus, and we don't really know how much she waters her ficus either. So, but if we do know how much she waters her ficus, let's say it's 4 gallons or 8 gallons or 12 gallons, she waters that 4 times more than her cactus. And the opposite of 4 times more would be like 4 times less, and the opposite of multiplying is dividing. So if you take her ficus, how much water she uses for her ficus, let's say it's 4 gallons for her ficus, you divide that by 4, 4 divided by 4, you get 1 gallon. So she uses 1 gallon for her cactus and 4 gallons for her ficus. And that would make sense. Or let's say she waters her ficus for 8 gallons. If she waters her ficus 4 times more, that means her cactus would be 8 divided by 4, getting 2 gallons. So anyhow, let's define our variable. F is the amount that she waters her ficus plant, whether it's 4 gallons or 8 gallons or whatever. Anyway, that is how you write mathematical expressions. Now you know how to apply mathematical expressions and algebraic expressions in real life like a real mathematician. Good luck. Go ahead and try that on your own.